simplifying rational expressions. So, you guys have heard of fractions, right?
Oh, no, I haven't.
You know what a fraction is?
What are you talking about, Nate?
Right? Like a fraction is like this, right? 3 over 7.
Don't bring it back.
A fraction. Fractions are like the most dreaded part of elementary math. So now, today, you get to learn the most dreaded part of algebra. Just like fractions were dreaded in elementary math, rational expressions are literally the fractions of algebra.
Oh no.
Okay? So here we go. This is an example of a rational expression. Here's an example of a rational expression. Something like this. X squared plus 5x plus 4 over x squared plus 8x
Oh,
plus
this seems like it would be easy though.
16.
But isn't there that whole thing where like you
Yeah, so we actually have already started looking at these, right?
It's not hard. Yeah.
We've already started looking at these.
Oh boy, more quadratic stuff and then you would
So you guys know what to do. What do?
you factor them. So
We
that's
factor the top and we factor
x
the bottom.
plus 4 and x plus 4 and x plus
Nice.
8.
Very fast factoring.
X plus 4 and x plus 4. Or x plus 4 squared. X plus 4, x plus 1. Parentheses. Take forever.
Alright. Now what could we do?
Cross out the x plus 4.
Yeah. Now, how come we can do that? Why can I cross out the x plus
Because you can't, so don't question it.
Because there's one on top and one on the bottom.
Yeah.
But like here, there's an x squared on the top and an x squared on the bottom. Can I cross those out?
Because they're separate, they're not together.
Yeah.
Like that whole thing is together.
Okay.
Like a big
The X squares are like Siamese twins, and then on the second one they got like
you separate the
separated.
Siamese twins, and then they can be in different rooms.
Okay.
No, because there's
They
the
couldn't
other
join
stuff
twins.
Think
that
about
adds
it.
to the x squared. It's not x squared, it's x squared plus 5x plus 4.
Okay.
It's not linked.
Right. So these are terms. These are factors.
Yeah, and
We
they're
can
both, like,
cancel
separate.
factors. Think about think about like an elementary fraction, right? If we had something like this, 8 over 20, you can reduce that, right? You can reduce it because 8 is 4 times 2, and 20 is 4 times 5, and I can cancel the 4 that's a factor. So I'd end up with 2/5.
You separate them.
But even still, why can I cancel 4 over 4? So are you telling me that x plus 4 over x plus 4 is 1?
Yeah.
Really? Anything over itself is 1.
Yes.
Is that actually true? There is one exception to
Zero?
that. 0.
And 0.
Right?
Well, I mean, 0
I
over
can't
0 is
cancel
0.
0 over 0.
Why not?
Well, but that doesn't matter.
friends don't let friends divide by 0. Technically it's a division problem. 0 divided
Yeah,
by
but
0.
I mean, 0.
Yeah.
Nothing.
I cannot cancel this. So, okay, so
Yeah.
come back together. So what do I have to say then? And this is the part that I hadn't taught you yet, or that we hadn't figured out yet.
Then it's
Is
done.
that I can cancel x plus 4 over x plus 4 as long as I do something called an excluded value. So I can say that this cancels and equals this. And then I say, usually we write a comma and just say x does not equal what? Because it can't be true. This cannot be equal to this if x is what? What would make this fraction 0 over 0? If x were
-4.
-4.
Oh.
Because if x were -4, we'd have -4 plus 4, so that would be 0 over 0. So as long as x is not equal to -4, this is a simplified version of this.
But you have to add that. The whole does not equal.
But we put in an excluded value. Now it depends actually. Sometimes you'll see different versions of these problems. Sometimes they'll just say simplify this rational expression. Other times they'll say, simplify the rational expression and state the excluded value. So this thing here,
Excluded value.
this is called, I hope this is on the video.
X-C-L-U-D.
No. Should probably move this because this is called an excluded value.
Always right.
All right? So the basic process here is not really anything new. It's just like taking those fractions you knew in elementary school and making them algebraic. So what did we do? I'm just going to write out the steps that we just did. 1, we factored the numerator, I hope that's how you spell it, and the denominator. Number 2, right? We canceled the common factors. Cancel the common factors. Number 3, we state the excluded value. Okay. Algebraic fractions. I was like trying to imagine, because you know, like when you learn fractions in elementary school, they're always like, think of a pie or think of a pizza, right? What would this pizza look like?
It'd be like a 3D pizza.
It'd be kind of weird.
I wonder.
All right.
I know.
Yes. Question.
Okay, I'm probably really gonna regret this, but why is this the most hated thing? Because it's so easy.
Well, so this is called simplifying rational expressions. Next, we're going to learn multiplying rational expressions. Then we're going to learn dividing rational expressions. So all these things that you learned with fractions in elementary school, right? You simplified fractions, you added fractions, and guess what? Adding 2 or 3 of these things together is a little bit of a nightmare.
Little bit.
Yeah.
Small.
Because if we want to add fractions, what do we need? We need the same denominator. And so it gets kind of complicated. We'll be multiplying by big things. And yeah. Question.
Before we learn how to like multiply and divide and add and subtract these, can we learn how to do that with fractions?
Yeah, we could review that. Sure.
Hey,
I don't either.
crappy elementary
That's okay.
school.
That's okay. Whoa. You know, some people remember things better. Some people
Or we just
learn
didn't
them
learn
better.
them.
Whatever. Yeah. So I think it's worth certainly reviewing fractions as well. All right. Let me just double check on your homework. This is pretty much it for tonight. Now, there are problems on your homework. There are problems on your homework that are simpler than this. Okay? So because we just mentioned this, what if I had something like this? 8r squared over 4r. Can we simplify that?
Yes, you can take out the R.
Okay, I can
You
cancel
take out
one
the
r, and I can
Yeah,
take
4.
out 4. So what would be left? I cancel the 4, there's what left here?
2R.
2. R, and there's nothing in the
Oh, it's just 2R.
so it's just 2r. Right?
Yeah.
What?
How do you get 2R?
So we canceled the r with one of the r's from the r squared. So there's just 1 left. And we cancel the 4 with the 8, leaving a 2.
Wouldn't that be a 4? 8 minus 4 is...
We're dividing.
Oh.
Because, yeah, fractions are like division problems. Good question, though. Right? 8 over 4 is the same thing as 2 over 1. If it helps you with problems like this, you can actually write the 1, right? Oh, 4 cancels, there's a 1. 8 cancels, there's a 2.
Well, I mean, the R cancels, that's just like 6, right? Like you're.
I mean, it's a 1.
No. Alright.
It is a 1. What about, let's do another one. Was there an excluded value for that problem? What would have been the excluded value in that problem?
-4.
It's actually really simple. So if we had 8r squared over 4r, what would make the denominator 0?
Oh, 4r. No, negative. Just
What would r have to-
0.
yeah.
0.
So the excluded value, if we had asked for it, would have been r doesn't equal 0. Sorry, I forgot to.
Oh, it's saying that whatever, like, you multiply. Okay, I get the.
Excluded value is saying, like, what would make this fraction 0 over 0, right?
Oh,
Or what would make our denominator
Yeah,
0?
the variable.
It's actually very similar to factoring.
Now I get it.
Okay, let's do another one. Again, I'm kind of going backwards. But let's do something like this. 90 over 18r minus 27.
Minus what? 27.
Actually, I'm going to add an r here.
Oh, okay. Okay, you
Let's
can
add
take
an
out-
r squared.
Okay, you can take out the r.
Okay, so what do I have to do first?
Oh, you have to do the thing.
I have to
Factor.
factor. How do I factor this? Can I factor the top?
Yes.
Not really. I mean, I could say 9 times 10 or something like that.
Yeah.
But it's not. That's not really that helpful.
And you take out a
How would I factor the bottom?
Ow. I just want to put myself in.
Ouch. Okay, in the bottom though, what do I do? What do I do here?
It's 7, and then you have to do things of 27 that can add up to 18, which is 3 and 9. No. Wait.
Because it's not r squared.
Oh no.
You can just
Don't you just take out a 9?
Yeah, you just take out a 9, right?
That's a lot.
This is 9 times 2r minus 3. So now what can I cancel in this one? What am I allowed to cancel?
The 9s.
I can only cancel the 9, right? Because that's the only factor that's in common. Can I cancel an r?
Wait, can't you cancel?
Yes.
Like, never mind.
Is r a factor of the bottom?
No, because it's multiplied by the 2.
No, because it's subtracted by 3, right?
Oh.
It's this minus 3 that I'm looking at here. I can't cancel something from just the 2r. I'd have to cancel the whole 2r minus 3. Okay?
Okay, so is that the answer?
So that's as far as you can go. with
Oh,
this
but you
problem.
have to find the thingy thing, so r would have to equal,
Yeah, r can't equal what in this problem?
7. I don't know.
3 over 2.
Why?
That's just because that would make the denominator 0. That's a little different because we didn't actually cancel an r.
I don't know.
Wait, okay, how do you know that it's 3 or 2?
Yeah, I'm confused
3
on
over
how you
2.
find the,
So basically what I'm saying is if 2r minus 3 equals 0, this fraction would be over 0, right? So how would 2r over 3 equal 0? Well, if I had 3 halves. I did that in one
so
step.
you just pretty much like kind of. Wait, what do you mean? How that's confusing? Why do you add 3 over 2?
I'm just solving for r.
Yeah, but why do you add 3 over 2?
We added 3.
And then divide by 2. Oh. Okay, because that just didn't look right.
Yeah, I did it kind of shorthand.
Okay.
Okay, and then, but then for the 10r squared, if it's 3, so like 10 times 3.
Well, it doesn't matter if the numerator is 0, right?
Oh, it's just the denominator.
Yeah. Now, it did matter if the numerator and the denominator were both 0.
So just 10r squared.
But
minus-
really what we care about is the denominator.
So that's just the answer. 10r squared, 2r minus 3r,
Minus
r
3.
equals not.
Does not equal 3 halves. Okay, let's do another one that's similar to that. What if I had something like this? X squared plus 2x over 5x.
Is that it? Oh, you can cancel out. Couldn't you factor by that? X is
Yeah, what do I have to do here?
factor the x squared.
how do I factor this?
X plus
X times
Okay.
X.
X
Oh, X
plus
times
2, yeah, times X.
X.
So this is tricky because a lot of these factoring, especially on your homework, are just pulling
Over
out a
5x.
greatest common factor over 5x.
So then you can
Now is
plot
there anything that I can cancel?
X from the beginning of from the unit.
Yeah, x is a factor of the top now, this x, right? So I can cancel this x here with this x down bottom.
X, it just looks like you're weird.
Yeah.
X plus 2.
No, you do like you have X like that, and then you do like a plus sign over it.
But then it looks like a star.
Alright, I just scribbled it out. X plus 2 over 5, as long as x isn't what? We have to go back and look here.
X would have to be 0.
X
No, X has to
cannot be
negative
0.
2.
Well, yeah.
Okay, does it matter if x is negative 2? Because that would make this 0, right?
Yeah. Well, no, but if you have 0 over 5, that's nothing divided by 5, and you can't divide.
0 over 5 is just 0, right?
But
We
that's
have
the
to,
same
so
thing, isn't it?
part of what we need to think about here is, what are we actually doing?
Wait, if X can't be X
Like,
can't be
why-
0 plus 2, that's just 2 over 5.
Right, right. So x, and this gets at exactly what I was just going to say. So x can't be 0 because we're saying that this, x plus 2 over 5, is equal to this.
Yeah.
Well, plug 0 into this. What do you get if you plug 0 into this?
Oh, you just get 0. 0.
No.
Well, yeah, no, because 0 times 0 plus 2 times 0 is 0. 0 over 0. Yeah, you get 0 over 0.
Ah, what is 0 over 0?
That's not solvable. 0.
Undefined is what
No,
we
but
call it.
I don't get why.
Plug 0
0
into this.
That's 2 over
What do you
5.
get? 2 over 5. So we just said that 2 over 5 is undefined.
Oh.
That's not right. So that's what the excluded value means. It's saying this fraction here is equal to this one here, as long as you don't choose 0 for x. But you could pick any other number. So pick another number, like let's say 7. Plug in 7 to this. So we've got 49 plus 14 over 35, which is 63 over 35. Okay. Are there any common factors in there?
Nope.
You sure? 63 is divided by...
That one I was looking at that
63 is divisible by 7, right? It's 9 times 7. And then 35 divided by 7 is 5, so it's 9/5.
Yeah.
Okay, now plug 7 into this. What do you get?
Oh, 7, 8, 9, 9 fifths.
9/5.
Oh my goodness.
So
It works.
this is equal to this for every x except 0. Yeah.
Okay, so I still don't get why 0 over 0 is undefined, because it's just 0 divided by 0. Nothing divided by nothing is divided by 0. It's all against the laws of...
Yeah, you can't divide anything by 0. It's like saying, so it's like saying this.
So if
Dividing by 0 in general. It's like saying this. I'm going to give you 3 objects. Put them into 0 piles. Is that possible? Can you do that?
No.
No, it's impossible.
You just
Well,
keep it in your
but if
hand.
you, yeah, you just keep it.
Well, that's one pile. The pile's in your hand.
Well, then float them in empty space.
Yeah. So there's no solution to that problem. I can't give you a number of objects and have you put them in 0 piles. I also can't give you 0 objects and have you put them in 0 piles. But that one's a little bit confusing. It's like, well, wait, wouldn't you just have nothing?
Yeah, I mean, like, if you put 0 objects in 0 piles, then you just have nothing, and then you get...
But the
And
question
that's 0
then,
over 0.
the question then is 0 the same as nothing?
No, it's just a concept. It's like a placeholder, and it like represents nothing. But that's why nobody had 0 a long time ago, because they always associated numbers with shapes, and 0 would represent nothingness. So
Okay.
they didn't have a shape for it. Therefore, their brains couldn't figure it out. Speak 0. I don't
Cool.
speak 0.
So anyway, we can't divide by 0, right? That's impossible. I can't give you any number of objects and have you put them in 0 piles. Right? It also makes people sad because, you know that traditional problem, like, I have 10 pizzas and I want to split them up between 5 friends. How many pizzas does each person
Oh, because
get?
you don't have any
Well,
friends.
then, if you're dividing by 0, you have 0 friends. And that's just sad, right? I mean,
Well, that's
no one wants to have
reality,
0
but, you know,
friends.
That's not sad, you
Okay.
get more pizza.
What?
More pizza for me.
You get more pizza for yourself.
Yeah.
All right.
See,
Well,
that